Hey YouTube, what's going on? It's Rocket here, and this is part 3 of my mini video series for my Traceback HackTheBox write-up. So just a little recap, in the previous video we exploited the backdoor and managed to get a low privilege shell as the web admin user, and from there we abused a Lua interpreter on the server to escalate our privileges from the web admin user to the sysadmin user. And after compromising the sysadmin user, we generated a public-private SSH key pair and then wrote that to the sysadmin user's authorized keys file. So in this video, I'll be showing you how we can escalate our privileges from the sysadmin user to the root user. So I've already logged in here as the sysadmin user, and I'm going to upgrade my shell to bash. What I like to do here is just like in the previous video, I like to run sudo-l to check my privileges. Since we were able to write to the authorized keys file, that doesn't necessarily mean that we have the password. And in fact, we don't have the password for the sysadmin user, but we can always try something like sysadmin. We get no results, so we'll try admin. No results there either. So I'm not going to bother guessing the password for sysadmin. Instead, what I'm going to look for is privilege escalation attack vectors. And one of my favorite ways to enumerate for that is by running this script called limpies, which I will show you right here. So you can go on GitHub, and it is by Carlos Polop. And this tool is actively maintained, so I recommend you go check it out. And Carlos Polop, you are awesome for developing this tool. And yeah, you can just go here and clone it, download it. Alright, I've already cloned it, but it is good practice to constantly update your tools because there might be a new privilege escalation trick that you may not be aware of. But the limpies author might have put that trick into the newest version of limpies. So this is where I've cloned limpies. So I'm just gonna update my Git repo by running git pull origin master. And it looks like I'm up to date. Perfect. So because I want to run this script on the Traceback server, I need to first host a local web server. Because what I'm going to do is I'm going to get Traceback to download limpies.sh and then execute it. And that's going to auto-enumerate the system for privilege escalation attack vectors. So go python 3-m to run the module, http-server, and the default port is 8080 on your public interface. Or I should say all interfaces. Next, I like to go to the dev shared memory directory, mostly because it is globally writable, and it's also a temporary directory because it's in shared memory. So as soon as you reboot the machine, all contents in that directory should be removed. It's also less known than /tmp, so if you have more people on the same HackTheBox machine, you're less likely to run into conflicts with them. Let's go there. And I'm going to run wget http, and then my p address is 10.10.14.48 on port 8000. Sorry. Yeah, port 8000. I'm going to get limpies.sh. So we download it. We can see that we did get it. We got a request from Traceback. Next, we're going to make it executable. The chmod +x command, and then we can run it. Another cool tip is that it is handy to run limpies as, like, every time you escalate your privileges to a new user, running limpies is beneficial because your new user is part of a different group, and it's also different users. So this means that they have potentially different read-write permissions than the previous users you used to enumerate for privilege escalation attack vectors. So another reason why I really like this script is it's very colorful. And if you search for anything that is red and yellow, it immediately stands out, and it becomes really easy to find privilege escalation vectors. You can also look for things in red, and which says, hey, you should take a look at it. So just the highlighting just the word highlighting makes it so much easier to find privilege escalation attack vectors, but don't always rely on that. Always double check everything. All right, so this looks like we are running a modern version of Ubuntu. So as of today, I doubt there are any kernel exploits available for this. So we'll keep going down. One notable thing here is cron is running. I'm not sure why cron is capitalized here. That looks a little suspicious. But we do know that cron is potentially running. And it's good to know that if cron is running, because if there's a writable cron job, we can write to that, and then we'll have code execution as the root user executes that cron job. So we'll keep going down. We've already wrote to the sysadmins directory. We have some backup file here. It does look pretty old though. And let's let this script finish running. And going up, we see something that stands out immediately. So if we remember when we logged in with SSH, here I can show you right here again. We got this greeting banner. And what happens is this greeting banner is read by the message of the day. So because we're part of the sysadmin group, it looks like we can write to these files here. And these files are executed by the SSH daemon. And the SSH daemon is running with root privileges. And I can show you that right here. So you can go ps aux and grep ssh. You can see that the SSH daemon is running with root privileges. So if we were to, let's say, edit this header file, we might be able to get code execution as root as soon as anyone logs into the server. So let's try that. Let's take this file here and we'll edit it with vi. So one of the simplest things to do when you get code execution like this is, I could do a reverse shell, but in this case, I think to me, it was just easier to just add a second root user. So to do that, we can take a look at the etc password file. And we'll notice a pattern here. So if we want to add a second root user, we can take this line right here and say something like, we can just echo it, but instead of root, I'm going to try to create the rocket user, and X means that the password is in etc shadow. However, we can also put the password in the etc passwd file if we generate one with openssl. So going back to my Kali machine over here, you can say openssl passwd, write your password, and you get a etc passwd password hash. So you can take this and put it in and we can add this as a entry in the etc passwd file. So I'm going to echo this, and I'm going to append it to etc passwd. Give it a save, and warning, this file has changed since reading it. Do I really want to write to it? Of course I do. So we've written this file. Now what I should be able to do is SSH back into the machine, and the SSH daemon will execute this command with root privileges, and then I should be able to switch to the Rocket user with my password and become root. So let's try that. So let's say cat etc passwd. Notice it did execute welcome to XH4H land, which is also here. And it's not there. So let's try saving this again. And we've noticed that this file has been changed again since reading it. So at this point, the first time I worked on this box, I was a little confused. But if what I did to troubleshoot further is you can use a school tool called pspy, which I will show you right here. If I can spell it right. So the cool thing about pspy is you can monitor Linux processes without root permissions. So it looks to me that this file that I was editing was changed while I was editing it. As a result, it only executed this line right here. So to figure out what is going on without root privileges, you can go and download pspy, which is a Go application they can use to monitor, like again, processes without running as root. So you can just go to the releases and download one. For this one, you want to download the 64-bit machine because the Traceback machine is running an x86 64 CPU architecture, and I've already downloaded it. So I'm going to get Traceback to download pspy from my Kali machine and then execute it so I can monitor what is changing, what is modifying this file right here. So let's go to tools, pspy, there it is, and I'm going to spin up the HTTP server again. So python 3-m http.server. Next, I'm going to go into dev shared memory, and I'm going to download this just like I did Limpies. By the way, I managed to complete this really fast by hitting Control R and then just type wget, and bash will recursively search your command history for the closest command you had. So download this. We have it. Make it executable and run it. So as this runs in the background, because this script is being modified, to me it makes sense to start scripting these commands so I can execute them in sequence. More what I mean by that is I was too slow, so by the time I finished editing this file and writing to it, and then when I logged in, the file seemed to have reverted back to a previous version. Okay, so let's stop this right here. So what happened here is we were monitoring for a command running with a UID of 0. A UID of 0 means that it is running as root. And it slept for root executed sleep 30. So it slept for 30 seconds. And then it said, hey, I'm going to sleep for 30 seconds again. And then after that 30 seconds, I'm going to copy everything from my /var backups.update message of the day directory to the etc update message of the day directory, and this file that we're editing here is indeed in this directory. So every 30 seconds, our edits are going to get clobbered by some sort of cron job running as root. So to get around that, we can do some scripting. So I'm gonna exit out of here. I'm gonna make a script called privesc.sh. So I'm gonna take this command that I had earlier, paste it here, and this is what I want the message of the day file to execute. However, if I'm going to script it, we're going to need to append all this to this file right here. So we're going to say echo this, escape the quotes, and we're going to dump all this to our message of the day header. And we need to execute this as soon as we log into the box with SSH. So this is another reason why it's very beneficial to go and establish your persistence as a user with SSH, and that's because you can script commands remotely just like this. So if I say ssh-i, and I think it was sysadmin.id rsa, then we can say sysadmin at traceback.htb. We can log in as a sysadmin user again through SSH, and then run this command over here. So we're gonna need more quotes here, bear with me. And because we have so many quotes, we are going to have to escape more of them. Well, actually, we can probably use single quotes instead, so we don't have to escape so many. Excellent. And then we need to log in as the sysadmin or as any user through SSH, so that we can trigger this command to get executed, because SSHD is going to take our message of the day header and then add our Rocket backdoor user as a second root user. So let's run this privesc script and see if we can't get root. So let's make this privesc script executable, run it. So okay, we logged in, and then we ran the SSH command, and then we logged in, and now we need to say cat etc passwd, and it looks like our Rocket user has been added. And if we take a look at the permissions for etc passwd, we can see that only root can write it. So this is confirmation that we have gotten remote code execution as root. So if you say switch user to Rocket and the password, enter their password, and we are now root. Let's go to the root directory, and there's root.txt, so we can see how many characters are in it. And it looks like it does have, well, 32 with a new line character, which is a hash, and that is the box. And so I hope you learned something, and I hope to see you in the next video. Take care.